Today, we get to show you an exclusive factory tour of FigureAI, one of the most exciting humanoid robot companies out there, and a sit-down interview of CEO Brett Adcock. Figure has been on fire since their founding just 2 years ago. They first launched their prototype Figure 1, quickly moved on to Figure 2, and soon they'll be announcing Figure 3, which we got to see in private.
Yeah, welcome to our current headquarters in California. We do all of our development and design work for humanoid robots. I'm excited to announce we'll be moving into our production facility in early 2025. Here we have basically a BMW workstation. This is where we do practice runs and do robot validation. It's basically a physical twin of what we would see at our client, where we have robots running through these work cells every day, basically get the robot ready for prime time.
Their blockbuster partnership with BMW has gone extremely well with a successful pilot, and now FigureBots will be permanently in the factory in January. Brett was gracious enough to give Scott Walter, a two-time robotics company founder, and I an unprecedented, no-limits tour of every department and access to many of their top team members. In the interview, I specifically focused on asking Brett the questions that many have been asking. What are their plans for manufacturing at scale? Why does he say they're one of the top leaders in the field? And when will they deploy their next customers? Humanoid robots are here. Awesome. Thank you so much, Brett. Appreciate you letting us come and visit you. This is a great opportunity for us.
Yeah, so what did you think of the tour?
Scott, why don't you start first?
I was a kid in a candy store out there. It's just incredible. And it's really tough to make me speechless, but it sort of is. And of course, part of the reason we're speechless is we saw a lot of things we cannot speak about. But it certainly gives me the background to let me know that Figure is absolutely for real. Everyone has said, is it CGI? No, that wasn't CGI out there. That was pretty remarkable stuff, no doubt about it.
Yeah, for me, honestly, what got me very excited is that there's so many groups and departments that you have working on, I think you said 1,000 parts, software, hardware, quality assurance, and then the caliber of the people you have, and you're an open book. And so I appreciated that you let us, you didn't hide anything, you didn't keep anything secret. We toured the entire factory. And yeah, Figure 3 is impressive. I know I'm not allowed to talk about it, so I'll restrain on that, but it's a huge leap. And then, in your design department, of course, that's the thing I'm excited about. And I saw the progression of Figure 1, 2, and 3, and the explanation of how this all changed. It's very rewarding to see the changes and why, and you can see the progress there. So, yeah, I have no doubt at this point that Figure 3 is going to be able to be successful as a production.
Yeah,
product.
And I guess you can say also like lessons learned. Quite a lot of lessons learned along the way, which is why you have so many different iterations and prototypes.
It's such a hard product, so like certainly the faster we can move between iterations and make a lot of progress between them, that's the goal. Yeah.
Okay, but what I want to do today is ask you questions that many of the people who are interested in humanoid robots have been trying to ask about Figure. So the first question is about your ability to do manufacturing, your customers, the ability for your AI and training, of course, how you compare to other robots, when is it going to be safely being able to work with humans, and those kind of questions. Okay, but so let's start with let's go with the customer. So recently, you guys announced, actually BMW announced the press release saying that it was a very successful pilot. So that was great to see that. And then you had a post, I think, that said the word permanently, like something like in January, BMW is now going to have your Figure robots there permanently. Can you explain a little more detail about that?
Yeah, we launched we launched into Figure 2 into BMW this past summer. It was great. We went to Spartanburg, South Carolina. We were there, on the use case every day for several weeks. It was most of the key team members were there, and overall, it was just a really great lesson for us of how to run real robots in real scenarios. And Figure 2 did incredible. We had a really good, we were up the whole time. The robot did really well, and we learned a lot. So we were basically now preparing for going into 2025, where the robots will be there permanently. And you saw it today, right? We have physical twins of that environment here. We're doing practice on it. I think as you were here, the robot was performing work. Robot's doing better every single week. And the goal is to try to make the work that we're doing here is transferable as possible there, and then continue that work that we're doing there on site, halfway across the U.S.
Okay. Well, what's the relationship with BMW? Like, are they paying for this? You said permanently how many robots will actually be there, but you've proven that it does useful work. You said 20 hours, two shifts like that?
Yeah, we want to do about 20 hours of useful work per day, 7 days a week.
Yeah.
That's a lot.
Yeah.
Yeah, BMW will be paying for robots.
Okay.
And we want to help as much as possible here. Like there's BMW's been just an incredible partner. There's several people there that really believe that this is going to work in a really big way. We have corporate support out of Germany now, and it's been they've been a really great partner. So 2025 year for us is like introducing that robot, our Figure 2 robot into BMW and try to make useful work happen every single day. And I think the caveat is just going to be like really hard. The robot's going to need to be, we're going to have to observe the robot to make sure it's always up, fix problems. I assume that will come up, and continue to scale more robots throughout BMW and also in new use cases as well.
Okay. And then so beyond BMW, can you speak to the next customer and your future customers? How many are there, and what's your next plan?
Yeah, we started with kind of like, we've been in discussions with many potential future customers here in the last like 6 to 12 months. We've started on the road with a certain party here that we can talk more of in the future. And our goal is to introduce Figure 2 into kind of multiple clients into early next year. I think from there we want to really try to hit really high performance, reliability, and safety goals with those groups. They're large enough where we can ship thousands of robots into them, and there's a certain amount of tax you have to pay, like integrating with a big company in terms of contracts and integration into their systems and just getting to know everybody better, getting robots there. So I think our goal is to get heads down and ship product that's really useful, makes it really work. I think that's really where the space is at right now. It's like there's a lot of good development going on, and the next big thing that we want to check off is can you walk in somewhere and see useful humanoid robots that are getting paid money in the world and doing useful work.
So what you're telling me, and I've seen it, right? So you're saying that BMW and its other customers are already seeing it do useful work. That's already hit that milestone, but there's a lot of learnings. But then you got Figure 3. You did an interview with Peter Diamandis. He dropped that there's a Figure 3. We knew that there was going to be, because Figure 1, Figure 2, Figure 3. So what is the time frame there? So generally, most people are saying that by the time you do a third generation, that's production level, right? So Figure 3 will be production at scale.
We will, our goal is as we enter next year is to really start scaling out the number of robots we have pretty substantially. I think we're hitting an inflection point now where the robots are really working really well. We need to learn how to do production at high rate. We need to learn how to get costs down substantially, and we need to learn how to run thousands of robots. And the sooner we can start on that, the sooner we'll learn and get better at it. So we're basically spending the rest of this year getting the robot to be a point where it can be pretty much general purpose in most use cases we would want to go into. And then next year we want to ship.
Okay. So the number one question that people have been asking about Figure specifically is, what is your plans for manufacturing? Okay. Yeah. Because obviously everybody sees that Tesla is, the king of manufacturing. They have multiple gigafactories. This is the thing they've been able to do for 10 plus years and longer. Then you've got companies like Sanctuary, who's announced partnerships with Magna, big, large factory that already manufactures automotive parts. Then there's companies like you, who's a startup, and everybody's saying, well, how is a startup who doesn't have experience in manufacturing, who doesn't have factories, how are they going to say that they can scale as fast as the other companies who have these kind of strategies?
Yeah. I think the short of it is we need to figure out how to make humanoid robots at a really high rate. Mm-hmm. And nobody's figured that out in the world. So we're tackling that head on. We're building our own manufacturing facility. We have our own manufacturing team. We're hiring people right now to design high rate manufacturing lines and equipment. And it's going to be really hard.
Mhm.
So again, the sooner we can start on that problem, I think the better. And I think this is a really unique product. I think one thing that you probably saw when you were walking around here is that, contrary to cars where you're building like a 6,000 pound vehicle that needs to be carried by giant machines all the way through the facility, that's got to be timed really accurately, have no bottlenecks. So you have as much, you can load the lines as basically as high as possible. Humanoid robots can be built and every part can be built and held in your hands.
Mhm.
And I think that's really an interesting data point. I think, we build 80 million cars a year in the world, and we make 2 billion phones. And fundamentally, the design process or manufacturing design process for phones and consumer electronics is very different than cars. So I think it's conceivable that we sit somewhere in the middle of that complexity trade between a phone and a car. We're definitely more complex than a phone, but we're definitely less complex than a car. So the short of it is we're going at this head on to try to figure out how to do high rate manufacturing. We don't have all the answers. I don't think anybody has all the answers, but we have the interest and I guess internal firepower to try really hard. And so we'll see. That's the next big step for us is how do we put a lot more robots into the world?
All right. Well, so talking cell phones, right? So Apple chose to outsource it to Foxconn to create it themselves. Are you saying that you're going to do all the manufacturing yourself? No, I get what you're saying because I saw it. Right? You have 1,000 parts, and every little part you can make yourself. And sometimes you will buy it if it's off the shelf because obviously it's low cost scale. But most things in a robot, you need to create yourself. It's all brand new. But then at the end of the day, it's small. It can be connected together. Are you planning to build? What's your plans for the factories themselves to actually do manufacturing at scale?
I think in the limit, we'll asymptotically approach a point where Figure probably makes almost everything on the robot over a long period of time. In the beginning, we will just basically make very rational, if you had to think about the entire bill of materials of a robot, like I say, a spreadsheet, you want to basically go through every single line item and say, what's the best choice here, both short and long term. Should we make it? Should we have somebody else make it? When those assemblies come in, should we put it together? Should somebody else put it together?
Right.
Who's testing it? When those sub-assemblies are now tested and built, they go into main assembly. How should that work be handled? Different than car as well as every system, actuators, battery systems, head, hands can be theoretically built in different facilities in the world and all come together onto a robot.
Yeah.
That makes it really unique. You can't put doors on a car that doesn't exist in the same building. Our strategy is we basically have we've gone down that whole list. We have a plan for every single one of those. Some of those are to use third parties to make certain plastic or metallic pieces overseas or to fabricate certain electronics in different areas. And some of those are to make it here at Figure. And then we will, as you go downstream, own more and more of the robot, even in the near term. So we want to be the ones putting the robot together, testing the robot, going through validation, and delivering to the customer and make sure that product really works. There's another side of this where it's the Apple side, right? Using Foxconn to build everything possible. Right. I think that's a really. I've always been a person that the saying is it's okay to have all the eggs in a basket as long as you're a basket. It's it's our destiny to control if we manufacture. Mm-hmm. It's really hard. I do not think there's you can have your cake and eat it too with using a third party. There's been majority of the cases are really bad, really end in tears for folks that outsource all that work to a third party that basically doesn't care about it as much as you do. Mm-hmm. The quality of the product, the quality of the testing. So we're gonna own it. We will die on our own sword if we have to. But I think it'll make us really strong. It'll be able to iterate really fast. And at the end of the day, we need to deliver a really high quality product. So I think it'll allow us to hopefully do that.
Okay. So this leads to the next question, which is another big criticism or the concern that people have when they think of Figure is that you're just now starting to think about manufacturing today. which is too late because you should have started thinking about manufacturing, design for manufacturing as you were designing it.
Yeah. So we've been thinking about high rate manufacturing and costs, which are relatively linked together since we started the company. We have folks that have come from high rate manufacturing backgrounds. We have folks that have been through DFM exercises many times over. And we have folks here that we've hired for, say, manufacturing engineering that have been through DFM exercises, basically line construction, equipment purchasing, assembly, and install. Like so I think we have like some good folks here that have been kind of leading us down a path where, as we get to Figure 3, we're at a place where we're high volume production ready.
Yeah.
And that is something we just can't think about yesterday or today or tomorrow. This just goes back years. And what that ultimately means is designing a robot from the ground up to do that. So I mean, high rate manufacturing is not new to us. Our first and second bot can never be made in high volumes, or you never want to make it in high volumes. That was intentional.
Yeah.
We spent all of our time designing a product that was feature complete, that can do all useful work a humanoid can do. That will unlock our ability to sell that performance to customers. And we have to do that now in a very low cost way. And the real way through that is high rate manufacturing. And so yeah, we're I think we're 2 years old, so continue to follow the story. And I think over time we think cost collapses, we think manufacturing volumes explode, and there's a lot we need to do around that hoop. It's we're doing it now. We're doing mini robots per week now, and it's very different than a year ago when we made one robot a quarter. We have to have manufacturing automation solutions we didn't have before. I'm fairly confident we'll have more lines of code in our manufacturing operations than we will the robot.
Yeah, more lines of code. Months. Yeah. Okay. Yeah. So the software problem is a lot more important than the hardware problem at the end of the day.
Yeah, I think ultimately, like for both probably manufacturing and the robot, most of this becomes a software problem over time.
Gotcha. Yeah, one of the things I was very impressed with the tour is, again, meeting all the key people, and thank you for letting them actually talk to us, not just wave. Their backgrounds is unbelievable. I think one of the things you haven't done as well that you could be doing is sharing more about, these guys are coming from all the right companies with all the right backgrounds. You're not doing it yourself. You've got incredibly intelligent team. You figure things out. So you've said that you are a Figure 3, which is blown away. I can't wait till you guys actually publicly present that. But I can tell you that it is just in many, many ways a evolution to what Figure 2 not only looks like, but what it can do. So that's going to be your production level. And you've said that you create many bots per week. What is your time frame? And when are you actually going to announce that you have a factory that's going to be able to do thousands and tens of thousands?
Yeah, so we're doing many per week now on Figure 2, as you saw today.
Yeah.
And it's great. I mean, I just have to say, like, I love this.
I know.
I know what I mean. Like, I just like I grew up like in the Midwest. Like, just this is awesome. We get to build things with our bare hands and make it really work.
Yeah.
It's just phenomenal. And the manufacturing process to build robots is just like enormously complex. And to be able to basically spend time on it is just like this really like basically mastery puzzle that you have to put together to really make well. And the robot's so sensitive because it needs to balance and move through the world and get in a lot of ways like sub-millimeter calibration and precision and very dynamic. So any line of code that's new, that's wrong, or any hardware piece that's not installed right or it's off and results in the robot like not doing what it needs to do. It falls or doesn't walk well, not as precise and dynamic as we need it to be. So it's like, we have to dial all those things in. And they're all like doable things. We're doing it right now. But we're getting better about at scale. We just like need different solutions. You saw like the automation we have on the manufacturing work that we're doing bring up that we didn't need on Figure 1. We need it on Figure 2. It's just impossible to scale without like exploding headcount without doing that. And even for the future generation robots, we'll need a lot more scale in automation to do that. The good news is we have a robot that can help with that. So I think in the limit, like I hope that we have robots building robots. Like what better way than to dog food our own product and get it to do it? And I mean, we're working with a car manufacturer, like,
Mhm.
you know, helping to automate very complex, you know, human type work. And it's really just difficult. So yeah, I hope we have our Figure bot on the line, helping make other robots. And, you know, we're not yet ready to announce like all of our plans for like high rate manufacturing and everything else, but we're making tons of progress on it.
Okay.
And, you know, I think the story here, as you guys saw throughout the chronology of robots, is like very linear. It's like everything serves a purpose. Every robot that we build and every year that goes by, we have certain things we need to check off the box. And before even we build 1 million robots, there's a lot of things over the next several years that we need to go check off. We're kind of in the exploding rocket phase of building humanoids, where we're still understanding how, like, where the upper bound is, which we don't know. We're still finding problems. We're fixing those. I think within the next like 6, maybe 12, 18 months, like robots are working extremely well day and night. I mean, we're seeing it now. We have like days that the robot just absolutely crushes, and we have days where the robot doesn't do well. We have to go fix. But the amount of things that we're chewing down the list, like the line of like problems over time, is just dropping. And it's even to my team. We were talking the other day, like the amount of issues that we saw on Figure 1 compared to Figure 2, that's probably an order of magnitude change. Like we go sometimes weeks without any problems.
Yeah.
We had problems every hour, every day on Figure 1. Yeah. It was just not designed to be reliable. There's a lot of steps we made in the system on Figure 2 to make it reliable, and it's been just really great. So yeah, I think hopefully everybody continues to follow our story, and we continue to hit the goals we need for 2024, and 2025 is really a year of shipping.
Yeah, 25 years shipping. Okay, so I've got a 2-part question here. One is, tell me how you think of Tesla, what they're doing right, how they compare to you and what you're doing, and then a lot of people are saying that one of the things that Tesla's got, not just manufacturing, but they've got the AI. They got one of the largest supercomputers in the world. What's your approach to try to match the AI? Because obviously you said a bot is mostly going to be a software problem, not just a hardware problem.
Yeah. We don't really have like a room or like anywhere we sit in here and say like, where is Tesla at? And like, how are they doing? And like, how are we going to we're kind of like on our own vector. Like we think we're like, I wrote, our vision for what we think the master plan looks like, when I started the company little over 2 years ago. It's on the website and the culture and the roadmap. And like, that hasn't changed. Like our end state is to go into the home. And the way through that, we think, is into the workforce. I think the workforce, through material handling, everything else, really gets the robot reliable, high performance, cheap. Yeah. And those are all necessary and safe. Those are all necessary to get in the home. The bottleneck is not like, if we had 1 million units today, we would just put them all in the homes. Like we still have this integration time it takes to integrate robots into the world and make them really work well. And so again, like same analogy before, like we're in the exploding rocket era for us. And in the next couple of years, we'll exit that era, and it'll be an era of like how many and how much data. Those will be the knobs you want to turn. The mini will help reduce cost as you get up the experience curve of manufacturing, and the data will help basically train neural networks to do human-like actions on the robot, which is going to be like as you're probably seeing some of the work we're doing here, just like an incredible time to be alive to make that really stuff work. So I think Tesla overall is like doing great. I think their vector of like where they're heading is like heading in the right direction. It looks like all I know is like what I can see kind of publicly. So I assume they have like just a really great team and great resources. So I hope they really do well. This is a space where I think it's a space where the most important perhaps businesses in our lifetime are going to be built, and the biggest. So we need to be very thoughtful about this. And Tesla's certainly a really great, thoughtful company.
Yeah. And then the second part was the AI question. Like there are some companies that have come out saying, hey, this idea that bot companies, including Tesla and you, are going to the factory first, doing these pick and place or very specific, useful work. It's not the right strategy, because it's better if you go straight to the home and have thousands of use cases and learning, multiple breadth of tasks. Will it be faster to train in AI neural nets to be able to have a useful robot that can do more tasks? What's your angle with do you need a large data center? Where are you going to get the supercomputer?
Yeah. I think that this viewpoint in general is just like totally false and wrong. I think it's wrong for several reasons. We're not at this point where the robots are just like work all the time and we're like data bound. Like we will be soon, but we're not right this minute. We really need the robots to get really robust. And we need to start with more, and like in general, the engineering challenge is like proportional variability. So the real question is like, you really want to start, it's like the analogy would be like self-driving cars. You're going to start driving on the highway way sooner than you are in the cities. The variability is just much less. It's much easier. You'll get up on the experience curve in manufacturing faster. You'll make more robots quicker. You'll ship them to clients faster. You'll make them more reliable. You'll drop costs faster. You'll get them safer. You'll just get like a lot more operational readiness. In the home, you have this issue of like having small children, elderly around. You can't injure them. The variants of tasks that you do, like dropping like the #1 mom cup in the home is very different than dropping a bin at BMW. So you just have like a lot of things in the home that are really quite challenging. I don't think people want other humans in there teleoperating through the home, moving slow, falling over in the early days. So I think what I'll say to that is like, let's see who can make it there first.
Right.
And we are intentionally building our roadmap to get to the home, I think, sooner than anybody. So we'll share more on that in our plan, but it's no different than what I wrote on the website several years ago. On the AI side, we were fortunate enough to be backed. My two lead investors for our Series B was co-led by Microsoft and OpenAI.
Right.
Microsoft has given us as many H100 indies as we need. So we've scaled up now 3 times the last like 90 days, actually, into larger clusters. So we are not, as of right today, bound by compute, for training and experiments. We, on the OpenAI side, have been working with them very intimately. I was there yesterday at their office in SF, working on trying to build new models that can work on our robot, that can ultimately lead to solving general robotics. How do you ultimately just talk to a robot and understand what to do, or show a robot what to do, and it can learn? And at least what I know publicly, we're making the best progress I've ever seen in history on that topic, from what I know we're doing now internally. And we will update the world more on that in the coming, in the near term. But we're making just substantial progress on that, which I think has been really helpful. And that's been constantly kind of pulling my timeline for the home, and the rest of the stuff kind of left on the sheet, which has been really, really exciting. So, like, as of now, we are not upper bounded by data and compute. At some point, we will be. Like, at some point, just more data does equal higher performance. More robots collecting more data will also help with more data collection. More robots will help with cost. So there is this like these knobs you can turn that are recursively almost like self-improving the business model. And we're not there right now. We think we can be there this decade, where, think about a figure bot will basically come to your house with a certain set of affordances of what it really can do. Those affordances will grow over time as it gets to know you better and you teach it more things. As we ship more robots into both the workforce and the home, costs will come down pretty dramatically. There's there's a lot of empirical evidence to show every doubling in manufacturing volumes can reduce costs in consumer electronics 30 to 50%. So you really want to make it high volumes. Like, that's really the game. High volumes also means more robots for data collection. So maybe to circle back around, it's we want to ship a large amount of robots as fast as we can. And in order to do that, the robots need to get reliable and robust as soon as possible. They're working in here, you're seeing it right now. Like, we just need that same thing in a really robust environment. And that's every day. We have a punch list. We meet every day at 8:30, and it's like, here are all the things to make it faster and more reliable. And we're working through those. And it's funny. It's like every time we work through those, like we're breaking into a barrier. We're breaking a barrier that we find in order to move the robot faster or make it more reliable, that we have to do a lot of work to go do it. It just doesn't come naturally. Robots moving faster through the world. Like, we have less frames to reason over, like camera frames. And there's just a bunch of stuff that that we're building that will help us do that. But like that's our focus, is to try to build a robust environment, like robots, and send it into the world. Yeah, so I'm excited about that.
Scott, do you want to ask your questions? Yeah.
Oh wow, yeah. I mean, I've got quite a
Scott,
lot of
like my
questions.
best time with you here in the lab was like you just like taking basically a magnifying glass out on the hands
Looking at the
and
hands,
just like touching it like all over the place, trying to break it, trying to move it.
and there's so much
Kermit,
about
you're
it.
like Scott's a robot hand guy.
Yeah. And there's so much about those hands I can't talk about either, which is a shame. I think one of the things that I can say was interesting going back there is where the assemblies are being done. There's so many spare parts that are there.
Right.
So that clearly your manufacturing are able to produce a lot of the components that you need. We saw a dozen Figure 2s out there already going around and in the process of putting those things together.
Yeah, and we're spooling up for the rest of the year. Like we got to build a lot more robots. They need 2 hands each.
Yep.
So we got to build a lot of hands, heads, arms, actuators. A
Yeah.
lot of stuff to do.
And so, yeah, we'll go through, I guess, a couple of questions. I mean, first, circling back to BMW for a second. So clearly there are some challenges remaining in what those are. And I think one of those that you sort of touched on is going to be like the uptime and the reliability, getting that. When you get that down, what are the other things that are remaining? Because I think I have some ideas, but if you can talk
Yeah,
about
the
that.
list is like really long. We need the reliability, which we measure on how many hours before human intervention to be like extremely high. So we do that now in our lab. We need that there. We can't be having humans intervening frequently, or you're just not going to be able to scale. So it'll be low in the early days. It'll get better over time. It'll just be a natural trend in technology. That's one. We need to make it safe. So there's a whole basically plan to make it safe. It's not like one day you wake up and like somebody comes in here and it's like you are finally safe. It's like it starts at the system architecture level at like a conceptual design review for a robot, clean sheet. Like how do you design this to be safe? And it comes with intent. Like where axiomatically you're driving all your reasons for being safe. Like for us, we're less important about somebody giving us a safe sticker. What's really important is like we build a safe system we can actually put in and it's actually safe. That's what we really care about. And there's different levels of safety needed for different companies we talk to or we work with that are needed in their facilities. That are set by those requirements are set by the company. So we need to be really safe. We need to be reliable, and we need to be high performance. So like in the workforce, they need a certain amount of output per hour, per day, or the companies can't survive. Like if you're shipping packages, you need to get a certain amount of packages out the door, or it's just like not going to work for your business. Right. So we can't go in there if we need 100 packages out an hour and we're doing 1 an hour because we're failing or we're just slow or our performance is just low. It's just not going to work. So performance is for us like, can you actually do the work? Can you do the work fast? And then over time, what's the reliability of that performance?
Yeah, and I just want to sort of touch on that is when it comes to the task, I think the biggest challenge that I can see right now is that you're able to place the sheet metal into the fixtures. The question goes back, how are you able to pick them up? Because the pickup points are going to be very random. You're going to be picking out of these very large bins, reach down there and get them. Sheet metal is notoriously sharp. It's very slippery. Is that sort of the main challenge that you're facing right now? And how do you think you're going to be able to overcome that?
The main challenge we have right now is probably doing this work with very high amount of hours to intervention. And it's right now. So we basically want to drive that up to, never, right? You would never really want a human to really intervene. So we're still like in some way like watching over the robot to make sure it works well. Every work cell is a human just basically helping right now, but over time we want just 1 human per 3 work cells and then no humans. So it's basically our biggest challenge now. It's just like getting it, like, I want you guys to come back in a month and just see the robot working, 10, 20 hours a day, every day. And then I want to see the same thing at BMW, which is going to be a different environment than we are here. We're trying to simulate what it is like BMW, but it's like never the same, right? It's like it's your lab. So getting out of our lab into a real client will be really healthy for us because we have to perform, which will be really good.
And that's what I'm thinking about. It's like pulling from the bin is going to be really hard because that's very unstructured compared to once it's in your hand, it's far more structured to be able to bring it over and place it in the part.
Yep, it's hard. All this stuff is hard. But we have behaviors and stuff for all this that we're doing and demonstrating here internally. We also have new things that we have to also get good at adding new tasks. Like you're saying, like you're like, oh, how do you do this or that? inventory or warehousing or material handling better. Like we have to get really good at scaling that. Even if we're good in a few tasks, or we have 50 robots or 100 robots working really well every day. Like everything that we see inside a company is a little bit different. That's why it's like so hard to automate. It's just like a thing here or there that would make it so that you have to redesign like the hardware or software like differently. And obviously you can't do that, right? So we're left with like, there's a lot of human-like stuff in the world that is like really hard to automate. And everything else that's easy to automate has literally been done. We're not like, it's been solved, especially at places like BMW that are really great at automation. So we also need to get good at not just doing X and Y tasks really well all day at high performance. We need to get really good at adding new tasks to the robot very easily without code. And that's also really challenging.
Yeah, that is a big challenge. And I think you mentioned famously back in probably December, January, that you thought what was going to be limiting everything was the AI. And then you started to see some things like, oh, wait a minute, we seem to be more hardware limited right now. And so
yeah,
that seems to be a real challenge.
Yeah, I feel like I missed that. I think like in the long term, like this is an AI business. So like AI, it's just like, it's all an AI business. It's not a business long term. Like, let's not forget that. Like the hardware will get really robust and good. It'll keep getting better. And then we'll just be like the software limited and bound the whole way through.
But right now the AI seems to have almost leapfrogged.
Man, it's like the neural nets we're running are amazing.
Yeah.
It's like the robot can like use a neural net to visual servo through a scene and do stuff like push sheet metal that like a 1 centimeter tolerance. And the neural net's great at it, right? It's like it sees the sheet metal, it sees where the pins and where it needs to go and the scene and holes, and it like knows how to just precisely place that. And if you had to build a controller to do that, it'd be impossible. Like your hands in different locations, and like you have to kind of visual servo your way around it. You have to be in a constant high calibration state. Just like impossible to solve that at scale. Yeah, we're like literally demonstrating it. It's working. We're trying to get to like 99.999% reliability. Like work on just making it really robust. But we've certainly have seen enormous tailwinds in AI, and I think what's really overlooked is how enormous that's going to be for embodied intelligence. The next leap is from out of a computer or out of a server into a robot, and that robot's going to be able to do very intelligent things in the world. They'll be able to have chain of thought reasoning. You're going to be able to plan, understand your surroundings, do novel things with the robot that it hasn't been specifically trained to do, and generalize. It's just an unbelievable time to put all those things together and make that work.
Yeah. Now, how much of that do you expect to be local on the robot, and how much of it, like you say, would? So with the famous demo with Corey and the Apple, where he was speaking to Figure One, the assumption was that, well, a lot of that was compute that was like remote from the bot itself to go ahead and understand language and everything else. How much of that do you think you'll be able to bring actually in the embodiment, or is it still going to be a situation that for some of those more compute intensive tasks, you would have to go ahead and have a connection?
Yeah. I think we make all these decisions assuming that the robot could lose access to the internet or 5G and still be able to do the work. Human can lose connectivity and still do work. We need to be able to like not talk to the internet and be able to do everything on board. Right. So we've designed for that here. No cords, no wires, no. You're in like almost like a GPS denied navigation state, but as it relates to the internet. We got to be able to just do the work and do inference all on board. So we have like multiple GPUs on the robot that are used for AI inference to run policies on and execute. But in reality, though, I think using like being able to talk to much larger models that are much bigger computers that can crunch much bigger numbers faster. Is a huge advantage. So we need to take advantage of that. So the question really becomes, how much time do you have to get an answer? Or how many computers need to crunch this problem? And in a lot of cases, when we're like, hey, go do the laundry or go put away, the toys out of the house or whatever it is, there's a lot of almost like preconditioning that can be done like off board of the robot, like trying to understand like what to do and how to go about solving that problem. And the rest of that can probably be, we call that kind of like long time horizon tasks. So if something's like a long time horizon task, you can probably offboard that, send it to a mega computer, crunch the numbers, get it back in probably a hertz, 1 or 2 hertz. So like probably talk to it 1 or 2 times a second.
Yeah.
And then things that need to be done locally, we can run that several hundred hertz.
Yeah.
So we can do an extremely fast computer or model that we can run to basically give it, maybe it's an action for the robot to do, like where to move the arm and hands and things like that. So I think it's the question you ask is like, how much time do we have to solve that problem?
And where does a large language model exist?
Well, large language models are small enough now to fit on a GPU, which we run on the robot, and they're also too big to run on GPU. That you need to run offboard. So there's really come a question of like, do you want to talk to a small brain or a big brain, and how much time do you have? In the case of just like mobile manipulation, of going in, like reasoning through the scene, say through speech, and then outputting actions on the robot, you don't have 1 hertz. You don't have time to wait every second for a new command. You need to run that very fast. And in the case of like, hey, I need to go put away the laundry, and I need to understand kind of the steps involved to go do that, like where I'm at, build basically a punch list, a mental punch list. Those could be areas where they're not, you have 1 or 2 seconds to wait for a command that are crunched by a much bigger computer that can talk to you and then execute locally. So those are things right now we're doing today. Like we offboard some commands to a big computer, and in a lot of cases we're using everything on local computer. Like models are getting like, in one part, models are getting like, it's almost like computer screens. At some point, computer screens on desktop got bigger, but on mobile got smaller. So they were getting like bigger in one case and smaller everywhere else, and like, basically like in this like state of divide. We're in that same way with AI models. There's like really big models that are really smart, and models are also getting smaller. We're like a 7 or 8 billion parameter model that we can run on a GPU, and they're getting really good. So I think the question all comes back to like, on this, like, do we do everything onboard or offboard? Do you have access to internet? How fast is it? Is that internet? And how much time do you have? Because if it's really fast, you can do it for everything. But that's not really going to be the case. You're going to be in situations where you lose connectivity.
Right.
You want the robot to still be doing the work.
And we're talking about the state of the art in 2024. Who knows what the state of the art is going to be in 2028?
I have to think models are going to get smaller and better. And we could also do better ways of doing inference on robot to make it so that we can handle like more latency across the stack. So I would say it's like, we'll see. But what's really exciting is we're doing this stuff now.
Yeah, exactly.
I mean, like everything we put out publicly is like, we don't speed anything up. We do like one continuous shot. We try to make it really authentic. We're really proud of it internally. And we want to use it as a way to help recruit the best talent in the world. I mean, you said earlier you met, Steve and some of the guys here. And I think the best thing I've done here is just bring on this incredible team.
Yeah.
They're fucking awesome.
They're a good team.
And I think I'm like so proud of it. And everybody here aligns well with their culture. They want to move fast. They want to ship product. They want to be a part of this mission to bring humanoids to life. Like everybody really cares. I'm sure, hopefully when you're like walking around and seeing everybody here is like really plugged in. They really want to make it work. They really care about being here. And they're just like exceptional in their field. There isn't a situation where we're like, oh, if we didn't hire this person, there's other personnel here exists. In most cases, it's like, this is the only person that exists to solve this problem for us in the world, and they're the best at it. So how do we like basically like, what do we need to go to dinner? Like, how do we convince you to come here to Figure? In a lot of cases, we just need people to come here on site, and we need them to see what we're doing. And I think it's, there's one thing to look at some stuff we put out online, but it's another thing to come here and see like everybody making this and running the robots. And we don't put out videos that frequently, so it's like really hard to get like ground truth on what's really happening. But state of the art here now is that we have like a lot of Figure 2 robots. We're making a lot more, and they're doing a lot better things than they've ever done in our history. So it's been pretty exciting.
Yeah, I think that's the first thing we noticed when we came here is there was no parking space.
Yeah, we're like
your fault.
Literally running out of space right now.
Yes.
Like we're just like we put the last several desks in last week on the far side. You can see this is the only conference room we have in the whole facility. Yeah. There's no conference rooms here.
Yeah.
That's it.
And you're expanding, right?
We're expanding. Yeah, we're going to move into our like production headquarters early next year, and it's going to be a very large upgrade to where we're at now. And the facility, it's funny enough. I actually tried to get this facility when I was running Archer. We were trying to move into this facility, I think it's like 4 years ago. And I walked in and I was like, this is amazing. Ended up going through negotiations, and it was like way too expensive
Mhm.
for us. We happened to raise just like, announced $1 billion transaction and stuff, but it was still at the time just too expensive for us. And I was telling Logan here, somebody we worked a long time, like when we were starting to look for space, like we needed something really special, and we called the guys back, and it was open. We went to go see it, and we ended up striking a deal, which has been great. We've been working on that, for the last 6 months. We're really excited to move in. We're like busting at the seams here. This office is nice, but like as you can see, like there's robots everywhere. There's people everywhere. It's just like
What's remarkable is what
Yeah.
you've been able to pump out in such a small area.
Yeah.
The density of what's going on out there
thanks.
is just
Yeah.
absolutely amazing. And I think that also comes down to like some of my other questions, like the lessons learned. So we had the opportunity to sort of see the original prototypes that you're working on, how everything has evolved. You clearly picked up a lot of lessons. And I think you mentioned to us earlier today this idea that you never like married to a specific design, which can be a problem with a lot of other companies where they think that, this is the way to do it, and they kind of stick with it.
Yeah.
And we've noticed that, when it came right down to, well, the Figure 1 versus Figure 2 torso is very different. The pelvis is different on the walking, where you move basically the actuator for the stride is now actuator number 1 rather than being actuator number 3. Your wrists, I think you told us a little bit about the history of the Figure 1 wrist and why the reason why it was so bulky is it was more or less just a time crunch and a bunch of other things that were kind of going on.
Yeah,
it's not like you intended it to be that way.
Yeah.
Just kind of talk a little bit about that and in your thought of like, you're iterating really fast.
Yeah.
And when you realize that the approach you're taking is completely wrong, you decide to not go down that avenue. And I guess the other thing is we know you have, I'm not sure what the actuator count is on there, but probably, 40, 42 actuators, something like that.
Yeah.
On all the joints. The hand itself has to be actuated in some way. And do you have any tendons anywhere in the body?
No, we have no tendons.
No tendon. That includes the hand.
Correct. We so I think one thing that is important, I think this is like good for like future entrepreneurs too to talk through, is there's a really large difference between trying building a technology company and building a product company. And they really it really fools a lot of people. Let me give you an example. So like a technology company would be somebody that is like probably a company that's like really obsessed with the core technology they've invented. They built the best, let's say electric engine for an aircraft that's shrouded. And they're like, this is the best shrouded electric engine of all time. And it's amazing. Mm-hmm. And they then put all their weight behind that to go build ultimately a product, which is like an aircraft or something like that. But it's all stood behind this like one part of the system. And I'd call it like a technology company. And the problem is people aren't buying technology. They're buying products and services they can use. So what you really want to deliver is a really good product. And a good product is like a pizza. It's got many slices that all need to go in, all need to fit together really well to make this pie or puzzle. A better example than a pizza. It's not just like, electric engine, it's the battery system, it's the way you architected the electrical system, the firmware and software and the manufacturing plan, cost plan and the reliability plan and safety plan, and all needs to be nestled inside this thing. And what engineering truly is you optimizing all of those parts to make the best global optimum. Mm-hmm. And what that ultimately means is you don't build the best subsystem possible. What that means.
Yeah.
Everything gets a little bit worse.
Mm-hmm.
The hands get a little bit worse. You have no room, and it's really far out, and it's got a really high inertia at the end of the lever arm, and it's got we can't wire a lot of power and comms through the rest of the arm, and you don't have a lot of space, you don't have a lot of mass, you need a lot of forces. So you just you ultimately have to make these compromises everywhere in the system, and so what we try to do here at Figure really well is to get the system level right for the product. We're not here to build the single best actuator on a test stand of all time. We're not here to build the best single battery pack on a test stand of all time. We're here to build the best robot that's ever been built. And that means we have to globally optimize that whole system. And that means we have to make small tweaks to everything possible to make that global system better. So we have no dog in this hunt on the subsystem side. We don't want to build the best standalone hands of all time, or we want to build the best product. A humanoid comes in, you can talk to and do things. And so that's really pushed us to think about what does the requirements look like at the end of the day? Like what does a customer really need? Talk to those customers, really understand that better, and really design for that. And every version of product that we're building out serves some part of this continuum of trying to get to this like ideal state. This perfect product. It's like unachievable. Figure 1 was mostly to get basically our AI and controls engineers, a robot, to do useful things. And, you know, it was ugly, right? Because like, I kind of say that now because we saw it next to Figure 2.
Backpack.
Yeah, it's just like wires everywhere.
Yeah.
It's just like, we're like, oh man, that thing is like, we were so excited about it for so long. And it was like, that looks ugly. But like, it was amazing how much we did so much great things with that robot. Figure 2 is our feature complete robot. It has everything we need in it to do full feature complete human-like work.
Yeah. And again, the lesson learned is that the torso or the spine that you had in Figure 1 just took up too much space. And so
we learned that the robot needs a lot more batteries, a lot more compute to build a independent embodied agent that can move through the world and do enough useful work per unit time. So like you basically need the robot to do a lot of output and work per X amount of time, and you need that to work all throughout the day.
Right.
And there's just no, and then the robot needs to carry a certain amount of payloads at a certain range of motions. That ultimately defines all the actuator sizing, that will define stiffness of the structure, that will define how much energy you need to power everything for a certain amount of time. And the rest of the sensors involved to carry out the tasks.
Yeah.
So it's like runs backwards from like the client all the way back into the robot. So we've been trying to recursively get that problem right, I guess, here. And I don't know if we'll ever get it perfect, but we're trying to.
Yeah, and that was, one of the things, just getting back to the hands, is that there's always been this mystery. I think I quipped out there this thing about, the Fermi paradox of robotic hands. If they exist, where are they? Because we've seen so many great designs. You just go out to YouTube over the past 10 years of these incredible robotic hands. We know the Rubik's Cube hand out there, and but we don't see them anywhere. So it seems like there's this big design challenge, and how do you come up with a human hand that actually has a lot of uptime and is robust? Because clearly what you're doing, handling sheet metal, you need to have a hand which is going to be able to last, not just a whole day, hopefully the whole week, without constantly having to be serviced. So what were the lessons learned there?
At the top, we are trying to do as much tasks a human can as possible. So you look at like almost the distribution of what humans do. We're gonna do as much of that as we can. Stretching to the far, like 99.9% is gonna make the robot just too complex in the early days. So like, humans have several hundred degrees of freedom. We're very efficient. Like our cost of transport is like much better than our robots. If you like measure like overall like energy efficiency there. So our goal is to do as much of that as possible while optimizing the rest of the system to achieve our goals of like shipping a product that people wouldn't pay for. We've not seen today an upper bound on the hands we're designing and making where the upper bound sits. We're unclear where we saturate this.
Okay, so you're looking at uptimes that will be very long. Meantime,
I'm looking at like, what things can our robot not do today.
Okay.
That we need to do.
And I was thinking sort of like mean time between failure for a lot of traditional robot hands out there is usually sometimes a matter of hours. And in your case, it seems to be a lot longer than that because you need that kind of reliability.
I mean, if you're going to push for a really high degree of freedom hands and complexity, I think the conventional wisdom is push actuators into the forearm and do a tendon-based approach. And those have proven to be extremely unreliable. They've proven to be extremely like under-torqued. As you move actuators into the forearm, you have a high friction to the sheaths and tendons, and become increasingly difficult to control. So I think higher degrees of freedom in the hands are probably necessary very long-term than where we're at today. But we have yet to saturate kind of where we're at now. If anything, we've been able to see pretty incredible amount of things done in mobile manipulators with very low degree of freedom hands.
Yes.
In the last year. I mean, pretty unbelievable research has come out in this space. So listen, our goal is the same as was before. Like, how do we build the best product? If the best product requires more degrees of freedom, great. If the best product requires less degree of freedom, great. Like, so we want to be operating in that global optimum. And yeah, we've yet to hit the boundaries there, but we're 2 years old, so we'll see.
Mhm.
I assume we will saturate out somewhere. So we're just trying to find that saturation point.
Right. So pretty much what you're saying is that Figure 2 won't be in a piano bar anytime soon.
Yeah, I think like, we want to do really normal things
Yeah.
in the home, in the workforce. There are some things I think Figure 2 will not do today. Like we probably won't sew, but like I don't sew.
Yeah.
Do you sew?
No,
Okay,
it's not
so-
part of my job description.
Yeah. Okay. So like, sewing might be hard. We never tried. We might be
Mhm.
able to sew. We've done very difficult things, like using tape and simulating other types of materials that like, look very hard on the onset that we were able to do very successfully. So we'll see. I think so far, look, the amount of things we've learned over each like design iteration has been enormous. We're making 200 to 300 bets every design. We're not getting all of those right. We're validating some of those that we did get right. We're understanding why we made some of those wrong, and those are getting recursively better.
Right. And I think you mentioned, and we can attest to this, is that even though that's called Figure 2, that's the 4th generation hand.
Yeah, that was our fortunate hand. We've done a lot of hand design prior to this, as you saw.
As we saw.
Yeah.
Okay. Well, so let's talk back to the bot. Again, just what I've heard from you saying that it can already do useful work. And then can you remind me how fast can it move and
Mhm.
when is it going to become as fast as a human?
We're currently walking around like 0.6, 0.7 meters a second.
Yeah.
It hasn't, I've seen it walk a little over a meter a second. We need the robot to kind of move around at close to like normal human speed,
Yeah.
just to be able to get the amount of output we need in our clients' facilities. So a lot of the work that we're doing, like, you look at the videos from the summer, it's just like the robots were just like, we're good end to end, but they were slow.
They're slow.
They're slow. And it just like ate away at me. But it was like my plan. It was like, get the robots to do end to end work really well, speed it up, make it more reliable. Doing that now. And it's great. It's like, it's in some ways like a lot more straightforward than getting the end to end work. End to end working is like, you can doubt that you could ever get to end to end, but once you get to end to end, I don't think you can really doubt how fast you can run. I mean, I showed you guys some of the higher speed stuff we're doing today on the robot. It's
And we saw the shimmy out there, and how you're working on that.
Yeah, exactly. The robot can move like really fast. So we're working on speed. It's hard. Like I think we've learned that doing standing manipulation and things like that are just like 100 times easier than moving fast and by like walking with moving fast with bimanual manipulation. 100 times. I mean, we were moving we were doing K-cups and coffee and stuff with our hands, standing around, moving things with neural networks like 8 months ago.
Yeah.
And we've been working on speed and reliability and everything else since, and it's been really hard. We're making extremely great progress there. Like we'll solve these things.
You said that it's going to be as fast as a human and
Yeah. Well, it depends on how fast. If like humans like sprinting around or whatever else, but like, as few of a normal human doing work, I think we'll get pretty close, but shy of that goal end of this year. And next year we will close that loop. And the loop we'll have to close after that is the overall reliability. Humans, like, they're doing work. They never really make a mistake. They like, knowingly. And the robot makes mistakes. Humans make mistakes. Like humans like will miss something, but you'll fix it. So it's almost like locally you'll make mistakes, but globally you want to make sure it's like actually got the job done. So the robot makes mistakes now. Some of those were self-correcting, some of those were not. We just got to fix those and make them really reliable. So that's another thing that we need to do. Large part of that is probably like a data play. Just get enough data collected to do that. So there's a certain amount of data needed to close that loop fully.
Okay. So the last question for you, Brett. Thank you so much for this time. But just summarize, what is it that Figure's doing that is different than the other bots? What is your advantage? You've claimed a few times that you are the leader in the space. What backs that up?
Yeah. So I think like what we want to do here is we want to ship robots in the real world and make them useful. Like nobody's done that today.
Right.
We're going to do it with a third-party client that will fire us if we don't do well. So we will find out. We'll find out soon enough. I think we can do that. I think we've put together probably the best team ever assembled in humanoid robotics in the world. I don't think there's anything else there that rivals the folks we have here. We have large resources. We'll have most of the cash we've ever raised in our balance sheet into this year. We have big groups like Microsoft, NVIDIA, and OpenAI like backing us financially and also commercially.
Right.
And I think we've showed that the robot can do really pretty amazing things so far on the back of advancements we made both in software and AI. And we want to back that up further with more proof that the robot's actually doing useful work, and then we want to make a lot of them. So, in some ways, the only way out is through here, and we think that we just want to build a really great business here. So we're all excited about trying to ship humanoids. We're less focused on trying to be a winner, loser, second, like whatever. Yes, we want to win. Like we want to be the best. But we're not sitting around like trying to compare ourselves to different groups week to week or month to month. We want to just build the best product we can as fast as possible. And so that's basically the core focus we have here. Yeah, I think like it's just an exciting time because I think it looks like this is the first time in history that this chapter opened up where there's like this window that opened and said, now it's possible to walk through this. It's gonna take an enormous amount of work. It might kill you on the way into the door. It probably kills some folks and it might kill you trying to do it. But there's like a door that open. It says like, it's possible today to go do this. And I think that's never happened in human history for this. And it's on back of the work that we're doing in both hardware and AI here. And it seems doable, and it seems like we have everything at our resources to do it besides pulling our pants up and just like doing really hard work. That's what we need to do now.
Yeah, thank you so much. I mean, Scott and I just thrilled to death. We got to visit you, talk to your team. Humanoid robots could likely be the most important, most impactful thing to society. At some point, we'll have to have that conversation about how do we make sure it's a positive future. Mm-hmm. But there's no doubt that it's going to be very supportive for factories and homes and people if it's done right. So thank you very much, Brett. Really appreciate it.
Yeah, it was great. It's good to have you here. Good to see what we're doing, and hopefully we can continue to visit and see our progress.
Yeah, looking forward to it. This was great, and we appreciate you taking time out of your schedule. We know how valuable it is.
Thanks, Scott. Thanks, Herbert.